All right, in this video, I want to talk about how to write linear equations. So what makes an equation linear is that it has a constant rate of change, and typically we refer to this as slope. Um, Slope is a really important concept in writing the linear equation, and what I've shown you down here is a bunch of different ways. So right here, we have 2 points, and when we're given 2 points, we would typically find the slope using the slope formula. The y2 and y1 technically do not matter. And the way I would tell you guys to do it would be to take the y value on top and the x value on the bottom. And make sure you put so we would have a -5 over 0. And then this -5 over 8. And those are the coordinates, so y is on top. And then we would add the negative sign from the formula in between and then perform that operation of math. In this example right here, this is in slope-intercept form from an equation, and this value right here is our slope. And so that one's pretty easy for us to figure out. Down here, we have a table. So to find the table, we need to find the changes between every coordinate and to make sure they're all the same. So we notice that all the x values change by, so here it changes by 1, it changes by 1, here it changes by 2, and here it changes by 1. So what we're going to notice here in a second is this y value changes by 0.2, this changes by 0.2, this changes by 0.4, and this changes by 0.2. So when we divide the y change, which is 0.2, divided by the x change, that would give us our slope. Now, the difference is here we have 4, 0.4 divided by 2, and that is going to be the same ratio as 0.2 divided by 1. So in this case, the slope for this table would be 0.2 divided by 1, and then you can simplify it in various ways. All right, over here, this is function form, and so what this really means is that 0, f of 0 means x is 0, and then y is 10. And so now we're able to create a coordinate. Over here, this tells us that 6 is the x value, and 34 is the y value. Now, because we have two coordinates, we would use the slope formula on this side. The last one here is from a graph, and what we typically do is start from the left side, and we want to know if we go up or down. In this case, we're going to go up, and we go up 6 and right 4. So if we go up 6, right 4, that gives us a slope of 3 over 2. Okay, so those are different ways to find slopes because that's going to be important later on in this video. All right, there's 4 forms of linear equations. We can talk about slope-intercept form, y equals mx plus b, point-slope form, function notation, which is slope-intercept form just with f of x, and then we have standard form. All right, so slope-intercept form is best used when we have a slope and y-intercept. It's really easy to graph equations as well. Point-slope form is great when you're trying to find something like a parallel or perpendicular line, which is what we're going to talk about towards the end of the video. Function notation is awesome to use when you're trying to evaluate. So if I had 3x minus 3 and we wanted to evaluate when x equals 2, we can write all of that in the function notation without having to do extra work or extra noting. Standard form is amazing to use when you're trying to find the x-intercept or the y-intercept. All right, so the x-intercept is when y equals 0, and the y-intercept is when x equals 0. You can also learn this little shortcut that the slope is the opposite of a divided by b. So in this case, the a value is in front of x. So if I take the opposite of 3 divided by the b value, which is -4, we get a slope of 3 over 4. So if you learn that little shortcut, that's an easy way to figure out the slope in standard form. Okay. All right, next, let's go through some examples. So in this example, we're going to write an equation given the slope and the y-intercept. Unless it tells you otherwise, typically when it says write an equation, you're going to write it in y equals mx plus b. All right, so our slope is 3, and our y-intercept is minus 9. And so we would have y equals 3x minus 9. All right, this next example, we need to find the slope, and we need to find the y-intercept. So going back to a few slides ago, we talked about slope from a graph. We're going to start from the left. And in this case, we go down 4 and right 3. So the y equals mx plus b form would be a negative 4 over 3, down 4, right 3. And then we find out the y-intercept here is given to us, and it's 2. So that would be the equation from a graph. All right, next, if we're given 2 points, first we have to find the slope. So our slope is going to be to take the coordinate and turn it so the y value is on top. I'm going to take 0, negative 7, so the y value is on top. And then in between, I'm going to add my negative signs from the formula for slope. A double negative becomes a positive, and that gives me a 7 on top and a 4 on the bottom. So now we have our slope. And in this case, to find the y-intercept is given because x equals 0 in the problem. So our equation is going to be 7/4 x minus 7. All right. Now, if they don't give you x equals 0, that becomes a little bit of a different problem. All right, if we look at this example here, function notation. So again, we're going to make this in the coordinate form. So f of 6 equals negative 2 really means 6 comma negative 2. And then here we would have 0, negative 5. Okay, since we have coordinates, we would use the slope formula to find the slope. And then we have an x equals 0, so this would be your y-intercept. So we would have negative 2 over 6, negative 5 over 0, and then we're going to put negative signs in between. We have a double negative, which makes that a positive. So negative 2 plus 5 is 3 over 6 gives me a slope of 1/2. And then when we write in the formula, it's going to be 1/2 x and then minus 5. Okay. All right, so next, point slope form is this form right here. It's y minus y1 is equal to m times x minus x1. Now in the formula, the values that have the little subscript of 1 is where the coordinates go. So here's our coordinate x, here's our y. So we have y minus y1. So this means the opposite of the y value. So the y value is 1. So in point slope form, that's what we would write. That slope in this case is 2. And then we have x, and then the opposite of the x value, which is minus 2. So that would be your equation in point slope form. Now we can expand this, which we're going to do in a few slides. What point slope form doesn't give us immediately is the y-intercept. But when we go to the next topic, we're going to see how we can get that. So now with all of that said, we're going to write an equation for a parallel line. So here's an example of a problem. We want an equation that passes through a point and it's parallel to this line. So step 1, we need to determine what slope we need. So the slope in the original problem is 2, and we want an equation that is parallel. So the slopes are going to be the same. Parallel slopes are equal. Okay. So what we're going to do next, step 3, is we're going to enter in the slope into our slope intercept, our point slope form. The coordinate here, x, is going to become the opposite of x in our formula. And then here we have a negative 4. And when we have the opposite of negative 4, that actually becomes a positive 4. All right, so the next step we're going to do is distribute. So on the left side, we're going to end up with y plus 4 is equal to 2x minus 10. And then the last step is to move the y value to the right. This is what I'm calling the y value. It's technically not correct, but I think think it makes it easy to find that value and tell you what to do. Okay, and then we have 2x minus 14, which is the answer. So these are your steps. Find the slope. Understand what slope you need to use, whether it's parallel or in the next example, perpendicular, and then enter the slope into the point slope form, distribute, move it over, and then you have your final answer. Okay, so now we're going to do perpendicular. Now, perpendicular lines are different because they are opposite reciprocals. So if I have a slope of 1/2, opposite is going to make it a negative, and then the reciprocal is going to make it a -2/1. So opposite means to change the sign, and reciprocal means to flip the fraction. So we can write this as -2/1 or -2, which is what's shown in the work down here. Same steps. Perpendicular slopes are opposite reciprocals. You have to know this. If you don't know this, you will not be able to figure this out. We're going to enter the values in. So our x value of -3 is going to end up becoming a +3. And then when we distribute -2 times +3, we get a -6. The original coordinate y value is 1, and it becomes y minus 1 in the formula. And then the last step here is we're going to add that y value to both sides to get y equals -2x minus 5. Okay. All right, now sometimes you might get some weird problems like this, and the idea is the same. We have to find the slope. This right here is in standard form, so we can convert it into slope-intercept form if we wanted to, or we can use our standard form shortcut. The standard form shortcut would be to make a negative a value over b, and that would give us -1/3. All right, in line B, this is in slope-intercept form, so we would have our slope here. And in this case, this is almost in standard form, but say we're not comfortable with standard form, we're going to make it into slope-intercept form. So what I'm going to do is take this 18x and move it over, and that's going to become a -18x plus 9. And then to solve for y, which is what we talked about prior lessons, solving literal equations, that's going to give us a slope of 3. And in this case, we're not too concerned about the y-intercept because we would typically want to use this slope to find another equation for, say, a perpendicular or parallel line. So the slope of this equation would end up being a +3x. Okay, so again, if you got weird problems, just figure out what works for you. Do you want to put it in slope-intercept form? Do you want to use standard form? Is it already in slope-intercept form? So we've covered just about everything you would need to know on how to solve these types of problems.